In this clip, we're going to implement a user story. We're looking at the handlers. Let me open the handlers that deal with orders. There's currently 3 of them: getOrdersAsync, getOrderAsync, and createOrderAsync. The team has assigned you a user story that consists of improving the testability of the order-related handlers. So the first thing to do is investigate how you can do that. Let's start a new thread. As mentioned before, you can also simply start asking questions in your code editor window directly. But for things like this, I think it is useful to have the full context of your previous prompts available to Copilot and yourself. The conversational style that Copilot chat offers really lends itself to that, in my opinion. But of course, you're free to work with this in whichever way you want. I'm going to start with the createOrderAsync handler here. What we need to do is improve the testability. Let's ask Copilot for a few tips. I need to improve the testability of createOrderAsync in, and then I reference the file orders handlers. How can I do that? And we get a lot of interesting suggestions. Replacing concrete classes with interfaces for dependencies, allowing us to mock these dependencies in tests. That's a good one. Abstracting DB context operations in a repository pattern or a similar abstraction also makes sense. Using dependency injection, allowing me to inject potential mock objects. Working on interfaces or abstract classes, the unit of work pattern, and so on. These are all pretty good suggestions. It even gives me a potential code example of how an order repository could look. It also seems to try and mock the complete DB context. Not sure if I'm a big fan of that. In general though, these suggestions are pretty good. If we abstract parts away, we can mock and thus improve the testability of the method. A DB context isn't the easiest thing to mock. In fact, Copilot already gave us this tip here about abstracting away the DB context. It did that by talking about repositories, interfaces and implementations that depend on the DB context. But I'm not convinced yet. Let's ask how exactly that repository pattern would improve the testability of the createOrderAsync method. So, how would the repository pattern help with improving testability? It tells me that the repository pattern is a pattern that mediates between the domain and data mapping layers, acting like an in-memory collection of domain objects. Through it, business logic can be decoupled from data access logic, and that offers a few advantages. I'm not going to read through all of this, but the main thing to get from this is that it does correctly explain what a repository pattern can do and why it is helpful in testing. In other words, now I am convinced. However, it only seems to be talking about an order repository for now. But if we look at our code base, why would we use an order repository to create an order with order lines? Wouldn't it make sense to use an order repository and an order line repository? In other words, what are the advantages of using one repository over splitting it up and vice versa? Let's ask. And we get a pretty nice explanation of the pros and cons of both approaches. Pros for separate repositories and cons, pros for combined repositories and cons, and even a recommendation at the end. It tells me to use separate repositories if order and order line have distinct and complex business logic, or if order lines need to be frequently accessed or modified independently of order. And that is in fact the case for our project, because we have endpoints to get order lines without including the order itself. We also have an endpoint that includes order lines together with orders, but the fact that we have this one here leads me to using separate repositories. Alright, let's go back to Copilot chat. And, well, let's generate it now. And, by the way, you don't have to follow Copilot's suggestions. So, what you can learn from this is that asking additional questions helps. Even though Copilot in the beginning suggested only one repository, even though I was working with orders and order lines, asking more explanation leads us to creating two repositories. So with that, we know what we're going to do. Now let's ask Copilot to generate some code for us. So the first thing I'm asking is to generate code for a repository named order repository. And then I reference the DB context. I also reference the file that contains the orders handlers. And I mention that I want that repository to work between create order async and the order manager DB context. So I'm being very specific here. I'm also going to ask it to put the repository in a separate file. And I want it to derive from an iOrder repository interface. So next to being specific, I'm also separating my instructions in different parts. Probably not all of what I'm writing here is required. I'm pretty sure that Copilot would automatically name a repository that deals with orders, order repository. But being specific in general does help. So I consider it a good practice to do it like this. Alright, let's have a look at what was generated. It defined an interface, iOrder repository, with one method in there, create order async. That makes sense because we stated that the handler we're working with was the one for creating an order. So we've got the order repository interface here with the correct name, and then we have an implementation of it with the correct name as well that depends on the order manager DB context. So that's a repository example. And next to that, it also included the modifications we need to make to our create order async method, so to the handler itself. It injects the iOrder repository and it uses that to create the order. It's even smart enough to state that we need to register the repository on our container. We're not there yet though. This is just one repository. Also, I'm going to be a bit proactive here. We're currently only working on the create order async handler, but the user story assigned to us actually included the other order related handlers as well. So I'm going to ask Copilot to generate the additional typical CRUD methods. Add methods to get all orders, get one order, update an order, and delete an order to the order repository. Let's see what Copilot suggests. It correctly extends the iOrder repository interface with the new methods that I asked for. And it also correctly suggests the implementation of these methods in the order repository. Alright, so with that, we've got one repository. But we need another one. We need a repository for the order lines. So I'm going to ask Copilot to generate that as well. And we could now again be very specific here. So I could ask it to generate specific methods inside of that iOrder line repository interface and implementation. I could provide names for the repository and interface and so on. But here's a cool trick. Copilot knows what we're doing. Copilot knows what went on in our conversation. So why not just ask it to generate something based on what it previously generated? And that's exactly what I'm going to do. I'm going to ask it to generate an order line repository, and I'm going to ask it to base itself on the order repository it generated. Let's see what it came up with. It understood that we want to create the order line repository in a similar way than the order repository. That's the first thing it tells us, at least. If you look at what was generated as far as code goes, we indeed see an order line repository with likewise methods as we found in the order repository. And the same is true for the order line repository implementation. So this is pretty cool, right? But let's have a closer look at that implementation. What I'm not particularly fond of in the code that was suggested is that save changes async is called on the context in each of these repository methods when changes have been applied. As you remember, we are creating an order with order lines. If I save the changes via one repository, for example after having created the order, then that will very likely mean that the order and the order lines are created in different transactions, depending on the implementation. I want the order to be created together with the order lines. In my head, conceptually, that means that calling save changes async shouldn't be done from inside of the repository itself. Using Copilot does not mean we should stop thinking. You should always be critical about what is suggested. Let's ask Copilot about that. So I'm asking it what I can do to avoid those calls. GitHub Copilot tells me that avoiding these calls can be beneficial for several reasons, including better transaction management. And that is exactly what we need. What it suggests is to use the unit of work pattern, which is a design pattern that helps manage transactions by grouping together changes that have to be committed at once. It also suggests a potential implementation. So it suggests me to define an IUnitOfWork interface and an implementation in which the order management DB context is injected, from which save changes async is called. So this means we are actually removing the save changes async call from our repository to the unit of work. That sounds like a good approach. So let's ask it to generate a generic IUnitOfWork interface for the unit of work pattern. What it suggests that I could do is create an IUnitOfWork interface with a save changes async method and a get repository of the entity method. This could make sense if we would be using a generic repository implementation. In other words, if we would have something like iRepository tEntity. But we don't. We currently don't have a generic repository implementation. Maybe that's a good thing to refactor to later on in this section. But for now, I don't want to go that far yet. So the thing that remains a fact is that you do need to still know what you're doing. What Copilot suggests here would pretty much screw up our codebase. So I'm not going to use this IUnitOfWork, but there is one additional thing here. If a unit of work allows me to save the changes, it should, in my opinion, also allow us to roll back the changes. And that's missing here. So let's ask Copilot to improve on that. Create an IUnitOfWork interface with a save changes async and roll back async method. And while I'm at it, let's also ask it to create an implementation of that for creating an order together with order lines. Next to that, create an implementation